I sound like a frog today. I apologize. But hey, everybody. I'm Ben Wagner. I'm a technical evangelist on the core media processing technology team at Microsoft. We're the codec guys. We made the video and audio parts of the Silverlight runtime, and we make the compression tools and products that get used to make Windows Media content and the VC1 codec, all that kind of good stuff. So I'm here to talk today about the AV experience in Silverlight, and really what can we do to get really awesome, take a really awesome advantage of that? How do we get best possible video and audio that works optimally in the Silverlight environment? Talk about general principles, also show off the new expression media encoder some, and talk a little bit about using our new advanced codec settings, which right now we have registry keys and will be incorporated in products later on, really taking coding up to the next level. So it's we haven't told the story a lot lately, but the video compression quality of the whole Windows Media codecs has been vastly improved in the last 6 months. So we got some great stuff going on around that. But that's what I was planning on talking about. But I know this is an interesting mix of this show of designers, business folks, programmers, that kind of stuff. So hope we take a couple minutes here, and you guys decided to stick around for the last session in Las Vegas to hear about media stuff. So in the next 75 minutes, what do you guys want to know about you don't know about already? So anyone's got something they just are absolutely dying to make sure they know about video compression during this session, let me know right now, and I'll hope I got it in there. So who's got a burning question they want to make sure they get answered? You guys are already tired. Yes, all right. Scripting and batch. Scripting in terms of like automation? Yeah. Okay, cool, yeah. Actually, batch encoding is so much better in especially media encoder than Windows Media encoder. It's awesome. It works. I'll demo that. So sweet, yeah. And we have command line as well. Cool. Excellent. I like questions we didn't mess up on. So good. Was the hand over here I saw somewhere? All right, anyone else got a burning question? All right. Yes. I want to know about the multiple live sources. You know, we're watching have multiple streams coming down at once that are all live. It's kind of dirt simple, really. You just you embed multiple live videos in there, and a video stream can either be live or on demand. It just kind of works. I mean, it's not from a design perspective. The way you do multiple live streams is you do more than one, and so it's pretty awesome. You have enough bandwidth that's available. We've got a lot of stuff going on there to reduce the bandwidth required to get high quality live content as well. So we'll be seeing the bit rates required dropping, given quality level, quite a lot over this year for doing the live stuff. So. A lot of cases where you might have enough bandwidth to only do a single live stream. Now you're able to do 2 in the future. So we're getting there. We're getting there. Yes? Providing captioning. Ooh, captioning's a totally awesome topic, and certainly for the government and education sectors. Captioning's been a huge deal. The nice thing is the Windows Media protocol and format has supported captioning data for a long time. This doesn't need a default way to play it back. And it'll be easy in the Silverlight client to do real-time text overlays and that kind of stuff. So you'll be able to do whatever kind of captioning and be able to choose your own fonts and the appearance and everything of it. So you'll be able to deploy a really good captioning experience. I'm not talking about that in this deck here, but you catch me afterwards. I'll be at the lunchtime thing. We can talk a bit more about that. But yeah, Silverlight's going to be a great client to deliver captioning. And it plugs into the way that captioning always was working up to the client end inside Windows Media. So existing captioning tools and everything will keep on working for that. Cool. Any other good burning questions? Cool. So let me show hands kind of the background of where folks are at here. How many people are actively involved in video compression today? A lot of you. Okay. Cool. How many people have ever actually edited a video piece in their lives? Most of you. All right. Cool. How many people have been using Windows Media as a video format? Flash. Okay, we have evangelism opportunities here. Perfect. Cool. So how many people think of themselves as an advanced compressionist? Only a couple here. All right. If I say B-frame, who knows what I mean? All right. Here, all you guys are advanced compressionists for that one. All right. Cool. So I've got this section of the advanced codec settings, which we either get to or won't, but you'll be able to get access to this deck later on, which has got some more details in it about some of the more advanced registry key things we're doing as well. So we'll just see how much time we wind up with and all that. So feel free to ask questions as we go along. This is supposed to be a conversation here, and we have the last of the 72 hours. So yeah, ask questions, ask for some demos. I've got a variety of things on here. Cool, and we'll dive in. And I'll be hanging around afterwards and over the lunch thing. You want to catch me, any other questions down the road as well. So, kind of overview of the video and audio experience in Silverlight. Awesome thing is right now it's Windows Media. Probably 80% of all existing Windows Media files that are out there today are already fully compatible with Silverlight. So in a lot of cases, someone's got an existing library, you see a lot of corporate training content done in Windows Media, they're already good. They just need to write a new XAML player front end, but they're able to use their existing servers, their existing content without modification, which is huge. Because it's just Windows Media, we've got lots of hosting companies that are available there. We have the widely deployed Windows Media Services is going to work with it there. We've got a huge ecosystem of compression tools at all kinds of levels that can make these files. Especially Media Encoder is a great product, but there's dozens of other products that can make Windows Media that are already available that'll be able to make content with it there. On the video codec side, Silverlight supports the Windows Media Video 7, 8, and 9 codecs. So obviously 9 is one to be using these days. And the 9 Advanced Profile codec is a recommended one. It's got the most flexibility in Silverlight. But pretty much all Windows Media back into the late 90s, those codecs are still fully compatible. Audio codec is Windows Media Audio Standard, which is not the voice per lossless version, but just Windows Media Audio codec. Again, that's backwards compatible a good decade or so. So talking about some very old stuff that's going to be able to just drop in there, and it's working out quite nicely. So you want to talk about there's a lot of branding around the VC1 codec as being the advantage of Silverlight. So let me just talk about why VC1 is an awesome thing for an RIA application, why we're using Silverlight, and also kind of the name thing a bit. So VC1 is designed by Microsoft, with a couple goals. Is we want to be able to have very efficient encoding, so we could drive down very low bit rates. The thing about efficient encoding means that you're able to get really good bang for the bit, which means you're able to give it at very low bit rates, as good quality as you can, but as you have more and more bit rates available, you really become transparent to the source. So you're able to do things like, high definition movies and movie trailers with film grain texture that's fully preserved and all that kind of stuff. So even very hard, complex video, the quality will scale as many bits as you can give it to the point really of transparency of the master. If you look at HD, DVD, and Blu-ray, over half of the advanced titles be made in the US today use the VC1 codec. So this codec, it's web video, it's on phones, it goes all the way up to high definition optical disc applications, so very flexible. The other key design goal we had for it was we wanted to be very efficient to decode on the PC architecture. A lot of codecs really designed assuming DSPs, dedicated playback hardware, something like that. We really want to target something that'll work well on a personal computer, with the kind of memory bus and processors and everything that's there. So obviously it would work well on computers because we're Microsoft and we care about software. So the general rule of thumb is we have about twice the performance measured in terms of how many pixels per second we can push to the screen. Given set of hardware, a given slice of CPU time, we can push about twice as many pixels to the screen in the same amount of time as competing codecs does. So it's pretty big. That means we're able to do HD on hardware that can only do SD in other codecs, which is a good thing. And also, it's a standard. SMPTE, the Society of Motion Pictures and Television Engineers, has made it a standard codec. It's fully documented. Anyone can go download full reference source code off the SMPTE website for both the playback and encode of the VC1 video codec. So it's even though Microsoft, we make our own implementation of it, it's not a technology we control anymore. We're just now another company participating in the ecosystem based around it. So sort of odd. So the VC1 name came later, but it retroactively applies to Windows Media Video 9. So Windows Media Video 9 is 100% VC1 compliant and always has been. So even a 4-year-old WMV9 encoded file is also VC1, same bit stream throughout. So there's no important difference between WMV9 and VC1. Two names for the same thing. We're going to try to get our brand a little more clear about that down the road. But as long as you're using WMV9, you're getting VC1 and all those advantages. So I will show you a little demo here, and we'll see how well this plays back in this environment. This display is a little bit blown out and everything here of Fantastic Four trailer, just to show how far along we've gotten with compression these days. So a couple of things I want to point out. This is a 720p video, so it's 1280y by 528. I cropped out the letterbox scenes, but it's the full image of the movie trailer in high definition. It's a full 24 frames a second, and it's a 4 megabit constant bitrate stream. That means if you have a fast DSL or fast cable modem, this will actually play in real time in a web browser environment. We've been demoing this clip playing back in Silverlight on Core 2 Duo laptops. So you play back in Safari and a MacBook, high definition in a web page, real-time streaming, which is a thing I, 10, 12 years I've been involved in web video. I imagine someday we get there. It's kind of amazing, actually. This is the year we finally locked down web video that really is high definition, which we can deliver to a pretty big audience. And even though in the US, 5 megabit bandwidth, there's tens of millions of households that have that much bandwidth, but not everywhere. Look at other markets like Korea, that much bandwidth is readily available. So there's a lot of interesting markets you can do delivering content that way. So let's pray to the video gods. This ancient laptop will play this video back. So I'm actually not going to use Silverlight to play this clip back because this is a slow machine and the way the projector's set up. But you'll bear with me. The demo of it is elsewhere. Whoops, where did we go? There we go. All right. The audio is going to be just good anyways, but so that's a slow-mo effect there, not dropping frames there, but you can see there. But we're really holding up. And this is 4 megabits. This is actually a little bit below the average bit rate for a DVD, at more than twice as many pixels here. And even with high motion, foliage, all that kind of stuff, we're really holding up pretty darn well. So let me just get in some of the crazy high motion effects, that kind of stuff. This is the kind of thing you have about web video would get turned into a blocky nightmare even a couple years ago. And this is the experience we're able to really give now. High detail, that brick texture is coming through, the reflections on the surfer, all that kind of stuff. So, and the audio is just going to be fabulous. The audio mixes a little bit off here in the room, but come by later on with some headphones I can play it for you. So this is really, with Silverlight, with broadband, with the VC1 codec, where we see web video is absolutely deployable this summer. This is not a long-term technology demo here. This is using the currently released codec, using the expression media encoder. This is all stuff you're able to get to the show today, and that works in the Silverlight today. So, flash is going on there, things like that. Just holds up. And in some ways, demoing perfect-looking video is kind of a challenge, just because you're like, well, what did you do to it? It looks like look beforehand. But we compress that file down from 1.5 gigabytes down to about 30 megabytes. So not a bad little ratio there. So that's where we are at right now. So how do you get your video looking that good? That's the challenge. So what does having WMV be the core technology for AV in Silverlight give content creators? One thing is, we just have some great video and audio codecs. We're able to deliver a high-quality experience using fewer bits than competing technologies. Or at the same bit rate, we can deliver a higher quality experience. Just efficiency lets you choose between, fewer bits or higher quality, or a mix of the two. It's nice. We have much faster encoding. It's a huge deal. Trying to get, in terms of time for market, getting content available up on the website quickly for live events, or just, from the capital cost of owning compression machines. We're able to turn around stuff a lot. Current benchmarks are on a standard kind of 4-core workstation. Your standard workstation these days, we're about 3 times faster at the same quality level than competing codecs. We have an option to use the Terrari card, which is a hardware acceleration board you can drop into any of these products, export the compression media encoder, and 15 times faster than competing codecs. Use at least a 5x speed improvement with a hardware board. So we're able to do faster than real-time 720p encoding now for file-to-file stuff. Which is pretty awesome, and much faster than real time for standard def. Pretty cool to have a live event that's 2 hours long. Half an hour later, you're able to have it up on a website, the complete thing. Our TCO for video hosting is huge. Windows Media Services is bulletproof, very well tested environment, widely deployed. Just works. The CDNs keep telling us how much they love us as a environment there. We're able to get many more streams off of the server than competing technologies. And it's cheaper, we're able to take advantage of multi-core hardware better, all that kind of stuff. With the Longhorn server, we're going to be doubling again our scalability. So the same hardware will be able to do twice as many streams yet in the Longhorn server. So I think it'll give us about a 4x advantage in terms of TCO, in terms of streams hosted, which is a pretty big number. Also, typically hosting providers charge less for Windows Media Services because we are more reliable and because we're more scalable. It costs them less per stream to host us, and they pass on those savings to customers for the most part. We also have good, mature live streaming encoding tools. So you're able to do real-time broadcast. Companies like Inlet are doing 1 year rack mount boxes for 24/7 real-time encoding, good stuff like that. So lots of good stuff going on there. So I'm talking about next kind of best practices. What can we do to get our content deployed to the web as high quality as we can? And the two biggest parts of it, actually, the compression part, is really important, but it's really the capture and the pre-processing elements where most video winds up losing quality. And really, in the end, the codec just takes the final formatted video, give it, and does what it is. Most web video that looks bad because the processing before the codec wasn't done well, not afterwards. So first, capture. Capture's pretty simple. As we get into the digital era, that's simplified a lot of matters. If you have a format that's actually available as a digital bit stream, like DV, DVC Pro HD, HDV, you want to just capture that as raw bits. You don't ever want to go through any kind of analog connection there because you're just losing data at that point. I see way too many live captures that you run off a DV deck with a composite cable going to a capture card. Anytime you go through a composite cable, you're going to mess your color up and you're going to lose a lot of your image data. And there's these days a composite cable's really got no place in a professional video environment. You want to be either doing digital capture or at least component analog. Other formats you should capture as uncompressed. There are lots of great capture boards out there that'll just take SDI or whatever you want to have and capture that as uncompressed and store it there. Storage space is, compared to historical trends, dirt cheap. The cards are only a few $100s for uncompressed capture these days. There's really no need to be adding any artifacts to your video after the capture process before you encode it. You want to give the codec as clean video as it can. There's those DV bridges that'll take an analog input, turn it into DV. And they're cheap and they're effective, but they're not super high quality. Often they're only composite arrest video in, and because they're taking analog video that's already noisy and then encoding it again, the DV codec is good for a lot of stuff, but when you give it a noisy source, it can actually wind up hurting the quality some more. That the same image that if you shot in a DV camera, so it's going straight from the camera to the tape, looks pretty good, but if it's a dub through analog, the additional noise means the codec doesn't have enough bits to do a good job. You want to grab the earliest generation dub as possible. I see way too much stuff that's clearly sourced off VHS, but it was content that wasn't posted on VHS. No one posted VHS tape, but that's all that someone had lying around. Or they had just the DVD. They ripped off the DVD to post or whatever. But the DVD was already compressed and might have had its own problems as well. Anytime you can go back earlier in the generation chain and go back to a Digibeta tape or a D5 tape or even a mini DV tape, whatever was the earliest generation final version of that project, that's going to be great. I used to, back in the 90s, do all the Nike quarterly sales meetings videos. And how that worked is they would send me a VHS tape, and I would send them back a good-looking file, a video, and they put it inside PowerPoint, and they play it back on their stage. It always looked really good, and they were always amazed. But our shop was a premium shop, was pretty expensive, and they wanted to save some money. They went to a competing shop and did the same thing, sent the guys a VHS tape, and they got a file back, and it looked terrible. And then 3 days before the show, they called us up, and they wanted to know if we could do it in a rush, and then there's the rush charge conversation and all that, and we did it again. And they couldn't figure out how come our stuff was so much better than the other guy's stuff, starting from the same tape. And what that guy didn't realize is, every one of those VHS tapes they gave us had the little asset number on there of what the project was. And so we got the tape, and then we called up their post house and said, I need the Beta SP dub of that thing. They sent me the high-quality master tape. We captured off that, encoded it, sent them the tape. Video looked good. I don't know why no one else thought of that. It seemed pretty straightforward to me, And so we were able to charge 4 times the competition, and it wasn't because we were encoding that much better than the other guys. It's just that we were actually doing the legwork to find the higher quality source. Because your output's never going to be better than your source, so you want to preserve as much quality every step along the ways you can go. The best approach these days you can do it is just grab the digital export from your editor using Avid, Premiere, Final Cut, whatever you want to have. If you're just dumping a file out of that and encoding from there, you've lost nothing at all. and that's ideal. So if you're in the position where you're creating your own content for delivery, it's simple to do it that way, and also a lot more effective. I mean, way too many shops wind up editing this great piece, and they dump it over out of video, and then they capture it on their machine and process it over there, and it winds up being, having to deal with the whole capture process and hurting quality there. So pre-processing. This will be the bulk of what I talk about today for this stuff. So you think about videos. You have these source video, and it's you have a frame of video that's some sort of weird shape and size. Maybe it's got letterbox, and it could be interlaced, and it could be some color space, and all these other things going on with it. And what you hand off the codec is actually the final frame size, frame rate, all that kind of stuff in there. And pre-processing is how do you transform those input rectangles into the perfect rectangles to compress for your video. And this isn't always something you're doing. If you just take up a product like Windows Media Encoder and say, this is my source, this is my output, it never specifies this is your pre-processing step exactly. But in there, it takes what your source size is, your output size, and scales it, and might do other video processing in there. Explicitly know what you're doing there, and making sure that's looking really good is a big part of making the quality very good. So I probably find in a challenging project, I'm going to spend probably 80% of my actual hands-on the workstation time processing the video. On the codec settings, you can't really know what the codec settings are going to be. You pick those, you tell it to go. So the computer's going to be doing a lot of stuff. But I don't have to be there for those. You got an A/B switch. You get a project ready, start encoding, switch back, do some email for a while. But the time I'm actually paying attention to it. I'm there making the video look good before the codec. And that's what really pays off. So let me just kind of walk through example here. This is an unprocessed frame of video. This is kind of a typical frame of video. You'll see if you just capture it. A couple things to notice here is it's interlaced. You see all those horizontal lines there? That's just, videos interlaced in the sense that the even lines and the odd lines are captured 1/60 of a second apart in NTSC. How many people are here from PAL countries or do a lot of PAL work? All right, so 50th of a second in PAL. I love PAL, by the way. I've threatened my wife many years we're going to move to England so we can work in PAL and avoid all these NTSC problems. But some of that is never a compelling enough reason for her. But so here I am. But, it's non-square pixels. It's a little bit stretched out. We have letterboxing top of the bottom. There's really no reason to ever encode letterboxing in your video stream because, if the computer's going to draw in one thing, it's black rectangles. That doesn't take a lot of CPU power. So easy to do. So that's a source frame there. And this is what it looks like we pre-processed it correctly. So notice the aspect ratio is a little bit tucked in, so it's square pixel, the right shape there. It's deinterlaced. We've got the luminance levels a little bit nicer there. And because it's deinterlaced, all of a sudden we realize, oh, those weird shapes, though, those are letters. It was obscured before. Next, you actually have weird text coming out of the spark here. Good thing to know. The wonderful coincidence is the best practices to make the video look good before you compress it also make the video compress better as well. So pre-processing is kind of like a force multiplier thing, where when you do that right, it looks better before you encode it, and it looks even more better after you compress it. So if you compare the same frame and code a couple different codecs, you can see the difference here. So this is, we take that source frame and compress it without any processing, and see some things on there. So the edge there, see that where the black bar is? It's kind of, the edge is kind of ragged. The codec's has a hard time drawing that straight up and down black line. It's very high detail there. All those little horizontal lines, the codec's spinning all of its bits trying to draw those little horizontal lines that shouldn't be there in the first place, and fewer in everything else. So you wind up with a lot of artifacts, a lot of softness there. Again, same number of bits, and we take the pre-processed version, and we get this instead. So, looks a lot better to begin with, and we're seeing fewer artifacts, less blockiness on here. So by pre-processing correctly, we're able to really improve our output. Clearly, the choice between having the same number of bits give you that image and that image, it's a pretty easy choice. So what do we do? We need deinterlacing or inverse teleciny. So Silverlight itself displays all video as progressive. So even though the VC1 codec can do interlaced video, you don't want to encode as interlaced delivering to Silverlight because then it'll come out as interlaced. So you want to convert to progressive at all times. Two basic modes there. If you got interlaced source, you want to convert it to progressive through deinterlacing. If it's video, there's a sourced on a film, so it's telecinied, you want to use an inverse teleciny to restore to 24p. And also, and ideally, if it's progressive video, you just leave it alone. Way too many tools out there will default to deinterlacing even if the source is progressive. But if you're creating content targeting Silverlight delivery, you want to shoot progressive, edit progressive, post progressive, go to your compression tool is progressive. You don't have to do this processing at all. And you'll encode faster, you'll look better, and have higher resolution to work with. So, we have a lot of interlay source out there you have to work with. But if you have the choice of doing this interlace to progressive is a much better choice and solves a lot of problems for you. So let me just kind of walk through. So source stream of video will look like this. And obviously, if you encode this, that's not going to look good at all. Distractingly bad. Weird ghost images, because the two things are two separate samples. In one field, in one set of lines, the bucket's there, the other one it's not. So you get the semi-transparent bucket with these horizontal lines. It'll encode terribly. The first mode of deinterlacing some tools do is what's called blend, which is somewhat better in that it takes some of the horizontal lines, kind of softens the two fields together, but you still get this weird ghostly bucket. And it's not a ghost movie, it's bad, so you don't want that. Next level up yet is you do what we call field elimination deinterlacing, where it basically just takes one of the two fields and just removes it and then interpolates what's left. If you ever use Photoshop, the video filters in Photoshop to do deinterlacing, that's what that does. And this is an improvement here, but you see you're getting some jaggies there. If you're trying to scale this down to 320 by 240, no big deal, but try to keep the same resolution, we wind up introducing these jaggies. The best thing is if your source is progressive, or if it's, you can do an inverse telecine, you can actually get the original frame back. And that's what progressive is going to look like there. Hugely, much better video. And also going to be the easiest to encode. Those little horizontal lines in there, those little jaggies, that's detail. Codec spend bits on detail. So your codec will be spending the bits on trying to preserve those jaggies and less than actually like the jungle scheme behind it. So you get fewer artifacts and cleaner looking video with a source. Okay, so cropping. TV production forever. We had this idea of the safe area because CRT tubes are kind of indifferent in terms of how big they were. And the general rule of thumb was that in terms of your video raster, the edges would not get displayed on CRT. We've got this weird transitional period now where if you have a DVD, it can play back on a television, where you don't see all the edges around the video, on a computer where absolutely you'll see every last pixel, or on a flat panel display where you may or may not see the edges, you'll see variable amounts of it. So it's kind of confusing here. So a lot of legacy content, you'll have kind of edge blanking. Maybe you might have like that flashing white lines at the top. That's closed caption data. Better to turn that into actual data and not transmit it as part of the video stream. So I could play back your caption data in the stream, but it was not going to be able to look at those flashing white lines I figured out for you on the fly. Any kind of edge blanking, you got white lines at the bottom. If there's VHS tape, there's tearing at the bottom. You want to eliminate all of that stuff. So any part of the image that's not actually part of the image you want to encode, just leave that out. There's no point in spending bits on stuff that no one's ever meant to see. You don't need to do an equal number left and right or up and down. Sometimes you'll have a video where there's this huge black bar on the left side, nothing on the right. All right, that's fine. You can crop just to where there's an active image area. That's fine. So let me just visually here, the frame here. So three areas here. We have title safe, action safe, and the full raster. You can see in this video here we got a little bit of black bar on the edge there. So you certainly want to crop at least that bit. Same on the side there. So the minimum amount of cropping you do on this for any delivery is to take out those little black bars. Because you try to embed this video in a web page, it's going to gray there. You have a gray web page to match. But you get these little black bars on the edge. It's not integrated into the web experience. Any kind of boundary that doesn't really want to be in there, something you can't really get away with. If you're going for really low resolution video, like below 320 by 240, you can crop even additionally. Because the cinematographer is never going to put anything that you need to see outside that action safe area. You can crop in a little bit. Make the foreground of it bigger. If you grab a smaller section of the video, what's left will be bigger. So if you want to get his face looking good in a very small window, you have a whole bunch of little video clips playing at once or whatever. You can crop in more aggressively as you go to smaller sizes. And the title safe area, any kind of lettering, motion graphics, anything you actually need to be able to read will be within that title safe area. So you can potentially go all the way down to that size as well, and they'll still be legible. Any of your crawls will be there as well. Image adjustment. If you download this document off of the website, there's a bunch of slides that shows you how to do this a little bit more, but this display can't actually show off it. So I lift the slides out. But computers have a really good dynamic range, and it's really good to be able to use that full range. One of the goals is if you have a video that's black, has like white text on a black background or fade to black, and you're embedding it in a web page, you have a black web page, you want to really have those blacks match. So the video fades all the way down, and you got the video embedded. You don't want to be able to see the seam between where your matte ended and where the video began. It's a good goal. And so you often have to adjust brightness and contrast to try to get your luminance levels down for there. And it's a little bit noisy, maybe some noise reduction as well. But that's kind of a good goal. That's one of the things that always bugs me for a lot of web videos. You look at it, and the blacks are at best dark gray. The whites are at best a light gray. But you never really get that full range there. If you're playing back video full screen, not a big deal. You're not going to really notice. Playing back video embedded in a web environment, you're really going to have full, pure RGB 000 graphical elements. The contrast can be pretty obvious. Noise reduction also, if you have noisy video, being able to reduce that to begin with can help out a lot. Video that was shot in super low light, for example, a lot of interview video, just has a lot of grain going on to it. It's distracting. It also doesn't encode very well. So noise reduction, if it's available, can help out a bunch. Also, audio normalization. A good rule of thumb is you want to have the loudest single sound in your audio clip match the loudest single sound the computers will produce. So basically, if someone gets some Outlook mail, the warning message about their mail shouldn't be a lot louder than your audio in there. Because classic web video experience, YouTube, for example, you got this. You're watching some video there, and you can't quite hear us, or we're not recorded very well, it's too quiet. You either keep turning the volume knob up higher to kind of hear what's going on there, because it's recorded to a low level. And they got their volume knob cranked up really high, and all of a sudden they get an IM message, or they get an email, or whatever, and or a system being a bong. And all of a sudden, this deafening klaxon happens, and their cats are sterilized. It's no good at all. So, you want to have your audio levels about -3 dB, about 90% maximum range. It's about what the system beep is going to be, so that they're not going to turn their volume up to hear your audio. If they've got their volume where they want to hear it for other system activities, it should be fine to hear your audio. I'm not a big fan of using things like compressors, limiters, like AM radio. Try to make it sound better, because a lot of people listen on headphones and that kind of stuff. I mean, if something is, if you mixed your audio for broadcast, it's going to sound fine in the computer environment. Okay, that's the pre-processing. Any questions so far about video stuff? Okay, sounds good. Yes. No, that was a camera. So encoding. There's a lot of options when you want to encode stuff. Kind of run through some of the basic core scenario decisions you have to make, how you're going to use the video, and how that's going to inform some of these parameters you're going to pick. So your first most basic decision is to know, are you going to be delivering through progressive download or through streaming? They're both appropriate for different stuff. Progressive download is coming off of web server, streaming is off of Windows Media Services, and progressive, you want to do 2-pass VBR encoding, streaming 2-pass CBR encoding, and just some more details on why you want to choose that. So first, progressive download. This is kind of a good default. This is most people's first web video experience. So progressive download, any HTTP server can do it. Obviously, IIS in 2003 server is popular, but any hosting service that can host a web page can host a video file through progressive download. And it's really just treated like it treats as a file end to end, and it downloads. Simple enough. You can do random access in the part of the stream that's already been downloaded. So you can kind of scrub through what's already there, but it goes back end to end. You can't skip forward past the point that's downloading. So you get the kind of experience, where you can this much you're playing like here, and you got this much of the downloads done. You can skip anywhere in that range, and it kind of keeps on pushing out as you download more. You can use variable bitrate encoding for that, because really the experience is based on what's the total file size. You don't care what the bitrate is at any given moment. You just care how big that file is going to be. With variable bitrate encoding, you try to keep the quality constant but vary the bitrate. So easier parts use fewer bits, harder parts use more bits, and you have a more consistent overall experience. So you're able to get your same peak quality level with lower data rate, so the file downloads faster. Progressive download is great for movie trailers. So things you watch end to end, maybe watch more than once. You don't really care about being able to skip halfway through a movie trailer. I mean, it's kind of a nice little unified experience there. Streaming comes out of Windows Media Services. You need to do constant bitrate encoding for streaming. The biggest advantage of streaming is it gives you random access throughout the stream. So you're able, you have a 2-hour movie, you've watched already, oh, I already seen this part. I'm going to skip 90 minutes into this movie and pick off where I left off. You can do that kind of random access. You can't do that in streaming. So that's the single biggest device. You also don't need to do any local caching of it. You need to have enough, a cache space available for the whole experience for progressive download. Someone's on not a very big machine, or they're on a mobile device potentially down the road. You want to do like a 2 gig progressive download file. They got to get stored 2 gigs somewhere in that device. It might not be there. In streaming, they just only need the bits they're actually working with right now. So much more efficient. So think about it. So streaming movies, long-form content, random access makes sense. It's a good fit for that. So you think about it. Progressive download is great for movie trailers. Streaming is good for movies. Good rule of thumb. So either way works. There's no one right answer. It really depends on what content you're trying to do and how you're trying to deliver it, the experience you want to have. So data rates. First thing I want to mention is kind of different from the computer world. Compression folks kind of came out of the whole telecommunications world. When we say K, we mean 1,000, not 1,024. When we say M, we mean 1,000,000, not 2 to the 20th. So I think a lot of people have been surprised about I was trying to make this file and it's like 7% smaller than I expected because you asked for megabits per second and it was actually power of 10 numbers, not power of 2 numbers, all that kind of stuff. So for you programmer types, this is why that's confusing. So when you're picking your data rates, in the streaming environment, the data rate of the stream needs to be less than the actual bandwidth available to the consumer. So someone's worst case bandwidth watching a stream is going to be like 500 kilobits. You need to have your video stream be below that and maybe 400 kilobits, some headroom. If you try to deliver 800 kilobits of video to someone with a 500 kilobit connection, it's just not going to work right because they can't get the video in real time and you're going to get buffering messages. So that's one of the things you got to sweat with streaming is what's the actual bandwidth available to the end user. And there's stuff that we're doing to make that better and things like intelligent streaming, so you code multiple versions of the file and it'll switch between that kind of stuff. But it's still a big factor. In progressive, the nice thing is, because it's just a download, the slower connection speed just means it takes longer for the file to download. If you've got like a 2 megabit file, they've got a 56K modem, it might take them a couple hours to watch a movie trailer, but it'll still work if they wait long enough. So progressive degrades a little more efficiently for high data rates. So you can kind of sweat that aspect a little bit less. Frame size. Square pixel is the most efficient encoding mode. So you want to convert to square pixel in your output. And your source video, typically like all the standard def video is going to be non-square pixel. You may have 720 by 480 video that could be 16:9 ratio or could be a 4:3 ratio, but it's never going to be 3:2 ratio, which is what 720 by 480 is. One of the classic mistakes I see in a lot of encoding is encoding video at 360 by 240 because someone said, okay, well, it's 720 by 240 is too big, so I'll just divide each by 2. I get 360 by 240 left. And yes, you get half the pixels width and height of it, but the source wasn't actually that shape. The video was either a 4:3 video, in which case a 320 by 240 would be a better size, or it was a 16:9 video, in which case maybe 432 by 240 would make sense. But 360 by 240 is never the right size for any actual video content. So when we're picking our frame size, the two things we're doing is one, we're converting to square pixel, and we're also going to be potentially shrinking it for the data rate. At high bit rates, you got like a megabit or 2 megabits, you can actually deliver it full resolution. Going less than that, you want to go down a bit. Kind of good rule of thumb is, for example, 320 by 240 is about 200 to 500 kilobits is a good range for that. 1 to 2 megabits is generally enough to be able to do full 630 by 480 or 832 by 240. Should be 480 there, sorry. My typo. Well, options there. You can kind of play around with it. It's somewhat content dependent. The slower motion the video, the simpler it is. The higher frame size you can go to a given data rate. The higher the action, the more detail to it. You have to kind of make the frame size a little bit smaller to make it work better. So encoding modes. Our codecs, we can have 1-pass and 2-pass modes. And 1-pass modes, it reads the source in and encodes it at the same time, in real time. And so looks at a frame, assigns the data rate, and puts it out again. And that works out kind of fine. That works out okay. 2-pass encoding, though, it does an analysis pass first, where it looks at the entire video end to end, figures out how hard every frame is relative to other frames. And then it goes back and it does a final encode optimally doing the bit budget for that. And the advantage of doing that is it's actually able to know what's going to happen in the future. Imagine you're doing a 2-hour movie for progressive download. The first half of the movie is people talking. The second half of the movie is people exploding. I think you've seen that movie. To get the right average quality, it might make sense. You might say, I want a 500 kilobit video, but the bandwidth breakdown might be, okay, we'll do the first half at 100 kilobits, the second half at 900 kilobits. If you're doing one pass encode, it has no way of knowing that, like, oh, the video's super hard an hour from now, so save all your bits for that. If you're doing 2-pass encode, it's able to do that. And even in the streaming environment, it's still got a few seconds to work with in terms of bandwidth. So by looking ahead, it'd help a lot there. So my rule of thumb is, unless you're totally crammed on time, use 2-pass encoding. 2-pass encoding isn't twice the time to encode. The analysis pass is easier, so it's maybe 20 to 25% longer to do a 2-pass encode than a 1-pass encode. And you get a very nice quality boost, much more consistent quality as well. With the 1-pass encode, you might have cases where the easy stuff looks better, but the hard stuff looks worse, which is not the right compromise. But with a 2-pass, it's able to do a good job of making sure it's keeping that quality average, taking the bits from the easy parts and making the hard parts look better. Two of the most constant bit rate versus variable bit rate. Basic rule of thumb is if you're doing streaming, you're going to use constant bit rate. If you're doing progressive download, you're going to use variable bit rate. Simple as that. Oops. There. Okay, frame rate. In order to get smooth video, without what we call judder, where the motion seems like it speeds up and slows down and kind of jerky, you want to have your output frame rate be an integer division of your source frame rate. So source frame rate's a full 59.94, that's a good frame rate, or half that, or a third of that, or a quarter of that. Same thing for PAL rates, 50, 25, 12.5, you want to divide by an integer number. And this is going to will give you nice smooth motion. If you're doing inverse telecine, for example, you're storing the video 24 frames a second. You want those 24 frame numbers. I see way too many movie trailers that were shot in 24 frames a second and then deinterlaced and then converted to 15 frames a second. So you've gone from 24 to 15, and the motion, like any kind of pan, you get this kind of very jerky like that. These days, with our codec, really, as long as you're targeting at least 200 kilobits or so of data rate, you can use the full frame rate of your source. So if you're shooting NTSC, you got 29.97, you can use that full frame rate for your video, and it'll look nice and smooth. And I tend to say it's better to spend bits on making your frame rate higher than on your frame size higher, except at very low bit rates. Because when you go to higher frame rates, there's less change from frame to frame. So you don't need to double your data rate to get double the frame rate. It's more like 20% more will let you double your frame rate. And it gives you this really nice smooth immediacy of it. So you want to get to at least 24 frames a second for your video to see nice and smooth. So I try to get there as soon as possible. Once I get to the right frame rate I want to have, then I look at spending bits on raising the frame size. So all good rule of thumb. Everything there, that applies to any format, any compression tool. Now I move on to talk about the expression media encoder, which is a new compression tool targeting making WMV files for Silverlight. It's designed to be really accessible to the designer community and the video professional community. We've had our Windows media encoder product out there for free for about 4 years, and the problem with things you give away for free is no one pays you to make them better. So we kind of haven't done much with it for a while. But expression media encoder is an actual product that will have a business around it, so it'll actually get better because people care. It is both offline and live encoding. Its coolest unique feature is it lets you build the whole Silverlight XAML project with it, so you can encode. It'll actually will build for you a directory with your video file, your XAML files, an HTML file, all that kind of stuff. So you got a full double-click environment table to play back the video and embed it. Huge time saver. And for video guys like myself who don't know from XML, it's the only way I'm going to be able to build a Silverlight presentation is if the tool makes it for me. Now that said, because Silverlight is just Windows Media, and XML, all that kind of stuff, there's no requirement you use this tool. This is another tool in the toolbox. It's an awesome tool for a whole lot of stuff, but this isn't the only tool you have to use. So lots of options out there. So all right, let me just dive in for a bit and show you some of my favorite things with it. This will be exciting because I got this build installed about 1 day ago, so we'll be learning together. Let me move a little bit so I can see my screen. All right. Oops. Who's seen the media encoder so far at all? Chance to play it around. So what do you think? All right. Okay. So tell me something you want to know how to do in it that you can't do yet, that you don't know how to do yet.
Show that the white showing encoding in the source.
Yeah? The
How do you do that?
okay, yeah, we can do that. All right. So here's the tool. It's not normally this is blurry. Sorry, the lens is messed up this projector here, but you get the idea. So that's a good segue to show. It is an NAB, and there are 3 features they loved of the tool. And their third most favorite feature was this one. We go, you know, this is kind of a soft projector. Let me just like up my resolution to my UI so you can read it better. How awesome is that? I don't know how useful it is, but now I can do my demo because you can see it there. So, all right. Where am I? Oh, where's my? Okay. Anyway, let me import the video here. So I want to just take some of these files here I was working on here. So let's take this little office file here. Let's do a small one here just to make it faster. So I got a file. You know what? I'm going to go back to that size because I can't see anything. So I got a file. You know, I can scrub and all does all the good things here. Where's my handle to drag here? Huh? There we go. All right. That's throwing me off here. So I'm seeing this weird squeeze version of it up here. So, all right. So you know, you get your video. You're going through here. You know, we got to understand the stuff. I can zoom in. I can look at it really big, and I can look at those pores and those things. So there's a couple of things I'm totally psyched about this tool. One is, I got 2 clips I want to add together. I got a trailer here. Let's grab that Fantastic Four version clip here as well. So, and work. There we go. Look, now I've got 2 source files concatenated. That took only about 12 years of compression tool development to make that to work. Here, I get a nice visual thing and some in and out points as I want to, and cut. We're going to cut there, and I'll go back a little bit, and I can go. You know what? Yeah, where am I here? Play the video here. I can be at my stitch point, and it'll give me a real-time playback there. There we go there, nice thing. So settings here, we can pick a lot of settings here. I'll pick a preset. What's a good, 512 DSL. This is a 320 by 240 thing. And I just got a preset I can work on here, and then I can modify it further onto video and go, okay. And that's the way I want. The frame is going to be the source, keyframe level there, the size. Actually, I wanted this source file is actually 320 by 180, so I can just change it there. I can modify peak buffer size, I suppose here in the audio, I can pick a different option here. I can drill down. I really want to make my audio. I'm going to do progressive download, so I can go to 64 kilobit stereo. It'd be fine for this kind of content, and it'll estimate file size based on my choices right there. Got a video complexity control, tells it how hard to work on it. So I want to get a really fast encoding, tell it to go down to 0. I want to make it super high quality when I can go all the way up. 4 is actually about as far as you need to go most of the time. 5 doesn't really help you that much. Got in and out points there, lock profile. I can actually unlock that and then do some additional cropping here if I wanted to change the size additionally or whatever like that. Actually lock the profile there. You can tell it to resize it, so if you cropped it out, it'll either expand to fit it or add letterbox and all that kind of stuff. Very nice preprocessing there. Show the crop dialog there. Let's get that here. You get an overlay option. Oops, why am I not that off there? There we go. So you have like a little graphic I don't have in here, but you can overlay a graphic, overlay bird, little bug, or logo in there. Of course, one cool thing about Silverlight is if you want to add a logo, you can do that through client-side rendering as well. You can make a nice little alpha channel PNG file and have that overlaid over the video and playback side. So you either choose to put it in the video on the encode side or put the video in it on playback side. And if you do it on the playback side, you can actually animate it and make it advertising or whatever. So you have a lot of choices how to do all that. I showed you the stitching thing there. Cool things here on the metadata side. I'm able to go through, title, author, all that kind of stuff. One cool thing you can do is markers. Say, okay, well, this video here starts with a few seconds of black there. So I really want to make the first frame of video a marker. So I say, add a marker, say first frame. And then it'll make that a keyframe automatically. I can say, this is going to be a thumbnail as well. Choose some here, and okay, they got a, whatever, she's talking about stuff. Thing there, I can add, interview. And this is pretty awesome that it's going to work in the final piece here. And I can say, oh, I want to do, and then we'll do another one first where the trailer starts. So, yeah, that's why you can't add a marker in the trailer, can you? All right, get on that. So a couple cool things in this whole thing is we can do this thing called A/B encodes. Let's see. I'm sure the edit there is actually work smoothly. I can hit this A/B and compare mode here. So the toggle goes in this mode. Go see these little green brackets here shows the region around which I'm going to preview. So I can say, let's grab this kind of region around here. I'll choose that there, and I want to build me a preview of that region. It's actually going to go through and it's just going to do an encode. See that little green bar in there showing how far it's in the code. So it's just doing an encode based on my settings, just that one section of the video. And I can actually do a real-time playback and see how it looks. This is the handiest tool ever. I spend my life making those compression tests and trying to compare before and after. What does it all mean? All that kind of stuff. It's just a huge pain. So, and then it's almost done. So where a fast computer really pays off. This is an old Pentium M box here. So, and I can't really see what's going on there. So I'm going to zoom in a little bit on my demo and play me back before. So it's. Yeah, this thing's not perfect, right? They can drag it back and forth. Look and see, okay, that's source output, so you can see how the effective the video is. And this thing's not quite 100% in this build here, but it's a great way to explore those video codec things there. And it's even more cool. It's like, this is looking so good. Maybe I could actually want to save some bits in here. So what if I said I want to encode this at 150 kilobits instead? I can say build the preview at this lower bit rate. A little bit faster there. I joke that compression is really the art of bartending. You're just watching bars go from left to right all day long. There we go. So you can see down here, original encoded. Here, I want to look at encoded 1 versus encoded 2. And I can see, and play back, the relative compression amounts. I know, it's a glitch in this build where it's quite a little bit out of sync. Because I resized the video? I did resize this video now. It's 320 by 180 for both clips. All right. They're on it. Got the people. You can bug those guys if they're... Anyway, but you can... it's not catching up. I recommend a good Core 2 Duo workstation is a good thing for this product. So, anyway. Once all the things that worked out there, it's going to be a very handy feature to actually do multiple test versions of an encode. Look how the different parameters you apply are going to affect the video. Good. So show that, showed metadata, showed output. Not sure here. So a couple things you can do: a thumbnail. You can tell it to find the most interesting frame, and it's actually going to analyze it to figure out what the best frame of this video is based on some heuristics. And make that a thumbnail for it. So that'll be like the thumbnail we'll use and build a presentation for it. You can also tell a specific one there. Also, you can choose a template. Actually, I want to make this, put this in the Blitz template or whatever. So actually pick a template. It will build a whole web page for you with a video in it. You get the whole automatic experience there, which is pretty awesome. Options there. So let me actually pull up a kind of complete project here I did for. Sorry, whoops. And where was I? Oops. So can we stop having XML be the extension type? Because I can't double click on my project file to open it up. Because they're all XML files, and they'll open up as something else. Open existing job I made last night. Oh, did I crash it? That's what I call a preview build. Oh, no, there we go. See, life is good. I was just joking. All right. All right, so this is a thing before you see these chapter marks here. So I can do a quick, let me do a quick comp render here and show how the whole presentation gets built here. I'll scroll up and down. So I got encode here. I go, okay, I actually want to make a, let's do just to make you show a fast example this is going to work here. I can turn on two-pass, make it a CBR encode, and make it a single pass. Oops. How did that happen? All right. I'm going to do a low complexity version of this video here. But you want to see is on the output side, I'm going to pick the, I don't know what's good. Modern, yeah, that's not what I want. I'll do the expression ones, good show for it. All right. Output, and I can just hit the encode here. It's going to go build it for me. So we got a little time frame there, and just it should build the whole experience. So it's going to look like in the end is. Where are they there? And one of these. This one? Give me a second here. Oh yeah, all right. Cancel that there. All my power is going to the. Try that up. Hello. So you're loading up the Silverlight thing. This is again, it's kind of slow computer, so we'll see how this works here. But oh, sorry, well, this is the one that doesn't have the. So you get the experience there. You get video playback. This is a web page, pretty simple here. I mean, I can resize it, normalize our stuff with it, and it's not a bad little thing. I mean, it's got the real-time scrolling in there automatically in there, so I can make it bigger and smaller here. And that was I didn't write a single line of code for that. That was all just the expression media encoder, give me a media player, and I got my controls, all that kind of stuff. So I didn't have to go in and actually build the GUI. There's one already built in for me. So beyond that, where did I put the good one? This is it. There we go. It'll actually build the. Where's the thumbnails here? Where's the last one I did? Until I was doing last night. Flip your party. Now, compressing video drunk is really an underestimated experience. Okay, bring it up. All right. This is working last night. Anyways, you give it where I set those thumbnail events right here. You actually get a little graphic pop up for all of those. You're actually able to do navigation and things. So you get the whole experience built, including navigation, including everything else built in there. And they were on there last night. Oh well. And so I do a preview release so we can go, because there's no better way to drive the developers than if you promise them you're going to be demoing live in front of an audience, and they get excited about fixing bugs there. So I'll have to get back to that one later on there. But it was working before. There's the thumbnail things. All right. So, yeah. So with EME, you're really able to build a complete experience around Silverlight. So a video professional, that a lot of design and programming experience, can build this thing. And then the designers that take over, and also you have the designers and the developers building these custom skins, and the video professionals get to apply. So it's really getting that whole separation of, we talked about the design programmer supporting both how they workflow together, and now also we've got the video people in the mix as well, as a third discipline that's able to work in the same tool set. All right. So any other questions about the encoder? You want to see anything else in there? Yeah. If you've been a long-term Windows Media Encoder user, you'd be happy to see this whole list here. Like, oh my goodness, MPEG, transfer streams, VOB files, .mov files. Yeah, so QuickTime source files actually work. Source file now. So this is... this uses the QuickTime API itself. So pretty much, if QuickTime Player can play back a file, pretty much anything that Windows Media Player or QuickTime Player on that machine can play back will import into Expression Media Encoder. So it does not support segment-based re-encoding. Yeah, no, we announced NEB, so we're doing a new API called licensed SDK called the Enterprise SDK, which will enable segment-based re-encoding for Windows Media-based applications down the road. It's not actually, we haven't finished it yet, so they haven't been able to implement it yet. Rosette did show off a beta, well, a pre-alpha version of using it to show grid encoding at NAB. So we've actually got people doing demos with that functionality. I hope to see, certainly by the end of the year or, at least a year from now, some segment-based re-encoding for Windows Media itself. We've had segment-based re-encoding for VC1, for HD, DVD, and Blu-ray for forever now. But, it's, well, one thing at a time, we only have that many code. Well, we got lots of smart people typing really fast right now, so we'll get there. So, other questions? Or yes?
Can you pull up some source code to show what the files look like embedded in a page?
Like the XAML, you mean?
Yeah, please. Just use source of one of the HTML docs, however it's previous.
Do I have anyone look at this? Let's see what's going to happen here. Oh, whoops, that's not going to do that. That's not what you wanted to have happen. You wanted me to look at my notepad or something like that. No, oh, I'm sorry. I'll get it right. All right, so open with. The default one. All right. Yeah, there we go. Sorry. I'll open an IE, just view source. You just tell me what to do, and sorry. I was trying to be smart and anticipate your needs, and clearly I'm not up to that task. I'm a recovering engineer. So I spent 2 years as a maintenance engineer. I'm writing banking software, and I've not been able to write a line of code ever since. Did I do it? Well, where'd it go? View, source. That's fine. Where'd it go? Did it close that too? Whoops, no, where'd it go? There we go. All right, sorry. Kind of underwhelming based on all that, I didn't realize, but that's because of us. So just got some scripts here. I'll show you the scripts of the XAML if you care about that.
That's good.
All right, yeah.
Cool, thanks.
So straightforward enough. You can see how you do that. And because it's a template-based thing, you can build your own versions of this that then EME can then apply to content. So
when you go to deploy a page like this, you're going to have to actually take all the scripts that it's generating as well and deploy them with you.
Right, so what you get is this whole directory here is everything you need to do. So you pop in a web server, you link to default.html, and then it uses relative URLs to do everything. All right? Good, yeah. Right, it uses direct show and the QuickTime APIs, both. So, it'll use direct show to read AVI files and MPEG and that kind of stuff. It uses QuickTime API to read .mov and those related files. So say that again? I can quite. In.
So let's say where you through the GUI was saying, do a testing code of this running to this running. If you wanted to do that in code via the APIs, is there currently an SDK or something that allows you to achieve the same thing programmatically?
Oh yeah, so for programming, there's a command line interface for the encoder. So you're able to you could script up, okay, this is my input, this is my output for this AVI file, encode it, and pop it up there. So the intent is it could be just a web service off somewhere. So you have a very good high-touch GUI interface for when that's necessary, but all the actual stuff that it does can be run as a service. So you have a server off somewhere, running it with QuickTime installed, reading that MOV files, translating to WMV, doing all that stuff for you. So. To introduce our own MPEG-2 compression codec? In Vista, if you have the Vista movie maker, Vista DVD maker, that actually has our own MPEG-2 codec in there. So we have an MPEG-2 codec. That's it's a very DVD-focused thing. Obviously, Expression itself doesn't support. Silverlight doesn't support MPEG-2. So MPEG-2 is kind of a legacy codec at this point. There's lots of third parties we work with who create MPEG-2 files. Well, our broadcast story, we're very VC1 centric. I mean, so we VC1 codecs available for a whole lot of most of the broadcast formats these days in the advanced world. We're very heavily involved in like IPTV and other environments. We're using VC1 as the codec for those deployments. There's plenty of good MPEG-2 products out there for that. So I'm not quite sure what we'd be applying in that regard. So. Oh, you want cheap? Oh, that's a different thing. All right. Well, if we did it, we'd have to charge for it too. So yeah, what's the 250? What's the pricing on? Has there been any public pricing on this yet?
Yeah, it's part of Expression Media. When it ships, so it will ship when Silverlight ships. And Expression Media is $299.
So it's $299.
And the whole Expression Studio is $599.
Or $599 for the whole studio. It's pretty cool.
Yes, if you buy now, they're shipping Expression Studio.
Hey.
You get the code when it's available.
Okay. Any other things you want to see in the tool? To generate client-side like overlays, I mean, you'd have to, yeah, you have to have the thing with the alpha channel in it. I mean, somewhere else. But there's huge numbers of server-side things that can do generation of those automatically. So that's that's not a problem. But yeah, the domain of this tool, you can't like type in text and have an alpha channel that. Well, that actually would be kind of a cool thing to be able to do is be able to at least do some overlays based on some simple text entry or whatever. I don't know. I promised the guys I won't give them any new feature requests for 2 more months. So let them ship first. It's pretty rich. You had a question about batching? Absolutely, yeah. So you just, if I want to import multiple files here, I can just grab another source file. And here I say I just got a. So yeah, just have multiple source files here. They got all different settings here. So you get a big batch. They'll encode one after the other. So yeah, we got batching in there. You can do save. When you save a project, you get saved as a batch thing. So you'll be able to bring it up again. It'll keep all the stats, everything, and of all your files. So yeah, finally batching there. Another big one is media encoder missing feature, nicely implemented. And you could also change the order of things you want to, and then things you can say, you want to move item down, move item up on the batch level. You can also just say encode selected, so it'll only encode a particular item if you want to do that. So it's got a pretty rich approach to be able to do batch management. Alrighty. Yes.
Did they have a demo version of any of this software available here?
The demo. This is up on the website.
Oh, you just download it.
Yeah. I'm showing off the build you can download. So I'm so glad I didn't crash it at all. So. Yeah, absolutely. Yeah, this is fully up. There's a news group up for discussion group up around it, all that good stuff. So it's up and out there. Great. Any other questions on the encoder? Anything you want to see? Alrighty. How much time we got left here? Was it? Oh, all right. Well, I thought I'd. Is there a yes? Yeah. I mean, you could add the clips together. I mean, this is not a video editing tool. This is really a content delivery tool. So any kind of editing, anytime you have to make a creative decision, that's going to happen upstream of this product. This can be some other kind of application. This is really about once you've got your final video file, how you deliver that. We've got some very lightweight stuff like leaders and trailers, just because those are kind of set of things you want to do. So you can kind of do simple append editing. But yeah, I mean, you would use a different tool upstream like Movie Maker or even very professional tools, Avid and all that stuff for authoring upstream of it. Yeah. So and the reason we support so many file formats is so we have a good integration story with the existing NLA community. Okay. So is it 12:30 or 12:45 we're done here? 12:45? All right, so I got 6 minutes left here. So, all right. Yeah.
Familiar with Camtasia?
Yes.
So, Team Allow we do a lot of Camtasia recordings. What would be the best output settings out of that before you
If you're using Camtasia, the Camtasia AVI file is the thing that Camtasia captures to be perfect for this. If you've got Camtasia in your system, it'll take that as a source file and code it. Now, in the past, we recommended the Windows Media Screen Codec as a way to kind of do screen recordings in Windows Media. Well, for two things. That's not supported in Silverlight, so, and also modern GUIs. You know, we have a lot of anti-aliasing effects, all that kind of stuff. The actual Windows Media Video 9 codec is a much better codec for encoding screen activity than the old screen codec was at this point, anyways. Yes, I would just recommend taking your Camtasia AVI file, grabbing it there, popping it in here, and you're good to go. Nice and simple. You can do your like trimming, editing, and all that kind of stuff in Camtasia. It's a great tool. Yeah, and Camtasia can also make a .wmv file. So you can even make a Silverlight compliant media file straight from Camtasia very easily. Not a problem at all. Quality-wise, yeah, I mean, if you're not doing any other video processing or the appending, you don't need other kind of stuff. I mean, these all use the same DLL of the system. So your video quality in Social Media Encoder versus another tool will be pretty equivalent. All things being equal. So you can just choose the best workflow for you. Okay? So how much time we got left here? So I want to... How cross-platform is what? Current output? Yeah, it makes a .wmv file. That's going to work. You know, anywhere there's a compliant player there. So the new version of Flip Format can play back those files, which I hope is released today. You're good to go. But I also use Windows Media Video 9, the old one. That'll let it play back everywhere. Not all players support the advanced profile. So if you're trying to make a WMV file that'll work in Silverlight and a bunch of other places as well, I recommend using just WMV 9. If you want to do it Silverlight only, use WMV 9 Advanced Profile. It'll use a little more flexibility. So I spent like a whole 5 minutes for you, the advanced compression folks, just point out a couple of things. Mainly there's a call to action to have you download the PowerPoint later on and look at some of the stuff about some of the advanced registry key settings. So one of the things that happened is this DLLs. We're doing all this HD DVD work on the VC1 codec to make it do really well, compression, all this kind of stuff. And we discovered all these great new options of the codec that we didn't want to turn on automatically, but we want to have in there in some way. And we just like panicked at the last minute, and we had to ship Vista, and so we just made them registry keys. So there's all these great things you can do that you have to set through registry keys that'll really change the codec performance a bunch. And I'm sorry. And I can't stand regedit. I mean, it's kind of a mean thing to do to developer types. So there's a lot. So first thing that happened is one of the guys in our team built this thing called the WMV Power Toy. It's the URL. Just download that. It's a great little tool. So you set all the registry keys, and it's got it's great toolkit documentation for all the options. So that's how you can do all this kind of stuff. And if you're really trying to squeeze out that extra last bit of quality out of WMV encoding, you can get a much better encode by changing some of these modes depending on your content compared to the default settings it ships with. And this works on Vista and XP, whatever, anywhere you can run, especially Media Encoder, these will work. These work in conjunction with that. So when you set these settings, then especially Media Encoder's version of the DLL will take advantage of those. Just a few minutes earlier, I want to cover some of the modes. So the new codec, we have 4-way threading, so you can do up to 4 simultaneous threads. However, it really works best if you have at least 64 pixels tall of the video per thread. So I recommend if you're doing like low-res video to reduce the number of threads you're using for the encode. It'll help your quality a little bit at lower sizes. And you can set that in there. It doesn't matter if you're only on a single core machine, it's only going to use one thread ever. But if you have a 4-core machine, sometimes it makes sense to do a 2-thread encode at a little lower frame sizes. Well, that's the thing called motion vector search range that matches the video for frame to frame and doing high def. It'll look at in a bigger area for matches. So you have really rapid pans or fast motion. It'll look at a bigger area here. It's a little bit slower in code, but we've got some options here, so there's bigger sizes here. The most important thing is that this new macro block adaptive mode. And what that does, it figures out based on each frame a bigger or smaller search range. So as your video goes really fast, high motion, the encoder will go slower for that part, make it look really good, and the easy parts will make it go faster. So in a file-by-file based encode, it's a nice compromise between getting good quality when you need it and good speed when you can have it. And kind of the different sizes here, I kind of like pops out in different levels of it. You can see how from that cue ball, if you have the smaller boxes, you're not able to catch where the ball moves from frame to frame. And it's more for high definitions. We have a chroma search mode now where we look for places where the color changes separately from how the brightness of it does. It's very useful in places where you have colors changing, but the contrast not very much. Motion graphics, cell animation are big places where that works. A pretty big improvement in that kind of speed. We've got a number of modes there, including, again, macro block adaptive mode, so where it kicks on when it needs it, but leaves it off when it doesn't. Also, can turn on B frames. This is the single best feature to really improve quality for both live and on-demand content. Where a B frame is a bidirectional frame where it looks at the previous frame, the next frame, but no frame is based in a B frame, so they kind of don't matter for future quality. By turning on B frames, one, you get more efficient encoding just because they're more efficient because they can look forward and backwards. And they don't need many bits because something's based on them, also more efficient. The best thing is we can, if you ever like strobe lights, flash bulbs, all that kind of stuff, we make those always B frames now, and so that we have like frame 1 is a video, frame 2 is a flash, frame 3 is the same video before the flash. Frame 3 can reference frame 1, and frame 2 just gets the scar after it gets played back. And all of a sudden you can do concert video with strobe lights, which was horrible to encode beforehand. Just turn on B frames, and all of a sudden they look perfect. Great feature for that stuff. Gunfights and discos. We're going to be using them on. It's kind of a structure for how the IPs work together. Loop filter, turn on, and this it's an in-loop deblocking filter. It finds where if you have too compressed, you see kind of errors between two blocks, and it kind of softens those out. And it's in loop, which means that when it bases frames on past frames, it bases them based on the deblocked versions of it, which means that when it fixes errors, it doesn't have to keep on fixing them in future frames. Helps a lot at low bit rates. It's worth always having it on from a quality perspective, but it does slow down your CPU decoder some. So, watch it if you're worried about, if you want to play back like 20 different clips at once, it can be an issue. This is the overlap filter, same kind of thing where it kind of softens where a lot of motion happens there. If you have blocky video, you flip this on, off, and the video will get a little bit softer, but it'll make the blocky artifacts go away. Also makes it a little bit slower, but good thing to turn on for pushing it. We have a median filter for very noisy video that kind of makes sure it doesn't ignores the grain a little bit when you're figuring out your motion vectors. It can help. Off by default, I recommend just better to just denoise it, but it can help a very noisy, grainy video if you want to keep that grain. We also have a denoise filter that's built into it. It's really good for real time only. If you're doing an offline encode, it's better to just pre-process it, the noise away. But if you're doing like a low light real time event, you can just flip that on. It'll help a little bit as some of the camera noise. We have a noise edge removal. You have like line 21 data. Again, you have a live video if you're just like stuff or garbage around the edge of the screen. It'll kind of find that and just kind of blank it out to black. Make it look a little bit better. Look ahead feature for doing live webcasting. So one of the big things I mentioned before when you're doing your two-pass encoding, it lets you look in the future. With a look ahead parameter, you're actually able to look into the future in a live encode. It basically tells the coder to look up to 16 frames in the future and buffer that, but don't make the final encode decision for that many frames. And so when you're doing a live encode, it's able to do things like, there's a big flash coming 5 frames from now. I'll be able to do some stuff. I'll do my flash B frame insertion. I'll be able to do some data rate stuff. So it gives you a little bit of two-pass quality advantage in a live encoding environment. It's a huge improvement for live event stuff. A couple modes I'll skip over, but called dequant and perceptual option. There are just ways we can optimize the codecs. There's a better job of doing less banding. It kind of helps video that should be smooth look smoother and that kind of stuff. We'll have more documentation about that pretty soon. We're still kind of trying to figure out how to document how to use these. There's so many different modes. It's kind of complex. But they're both good they can both help a lot from video stuff. So, and again, you want to download this off the website later on, but these are the optimum settings for both flavors there. Take a look at there. All right. Also, I should mention there's going to be some training around all this stuff here. They asked me to put a slide in here for 2 days, some details about it, all that stuff, to learn more at those places. So, doing all right. So that's my content info. I do my email. If you guys here to get this, just email me. I'll give you a download of it. I've got a blog about compression stuff up on 10. And I also teach a week-long compression class at Stanford University in the summertime where we'll be talking a lot about Windows Media and Silverlight and all that kind of stuff. So if you think an hour of me was too little, then I'm highly surprised. But you can get 40 hours of me there in August. So. All right, and I think that's probably about 5 minutes past the time I've got. So do your evals, and that's our logo. So, all right, thanks.